In this one, we are going to go over this concept gradient descent with examples. So in previous one, we learned how to calculate derivatives when you just have the one training example, and in this one we are just going to look and get to know how to deal with multiple examples. So the we'll go for training examples with this function j, w and b as 1 by m summation I equals to 1 to m L of ai y. So overall cost function is like just the sum of our average of the individual losses. So that's the whole thing. So this is a. So in previous thing, just as we learned, we have to calculate derivatives when you just have one training example, and when we have a lot of training examples, we do this thing. So it turns out derivative d by dw j w comma b, that is going to be the similar thing 1 by m summation of I equals to 1 to m and this thing will be ai and yi. So there will be multiple a and y things. So dw1i is going to be xi comma yi. So that thing is going to be so erasing the derivatives from previous example will give you overall gradient that you can use to implement the gradient descents. So I'll try to make this concept more in the like conceptual manner. So imagine you have toy box full of toys like blocks, dolls and cars. You want to predict whether someone will like certain block or not. To do this, we need to catch the computer how to recognize patterns in the toys. One way to teach computers is something using called logistic regression. It's like teaching the computer to guess whether someone will like the toy or not based on what they look like. So here's how it works. We show the computer some of blocks and it will tell if each block liked or not. Second, the computer uses this information to learn patterns, like if a block has a red color, it's more likely that someone will check it. And third, once the computer learns that these patterns are there, we can use it to predict whether someone will like a new block or not. So now let's talk about how computer actually works. So we need to tell the computer some things. First, the toys, block, dolls and car that we are using. Then second thing will be how many features of each toy, like how many sides does the cube have, or anything like how whatever the features are, and if someone will like or not like the block. So we also need to teach the computer something called gradient descent. It is like a game where computer tries to find the best way to predict someone will like a toy or not. So gradient descent is like a ladder that helps computer to get better and better at predicting. So the first step of ladder is to make some predictions that will be based on what we have thought so far. So I hope the concept is getting clearer. So let's wrap the whole thing in the concrete algorithm so we can get logistic regression and gradient descent working. So uh, we have this formula, and in this formula we are going to assume j equals to 0. Then dw1 equals to 0. This is dw1 is equals to 0. Then dw2 equals to 0. And after that db is equal to 0. Now we are going to write something in that will look like Python. So we are going to write a for loop where I is going to be 1 to it will going to go until m, and we are going to compute these with respect to derivatives of each running example and then add them up. So the z of I will going to be equal to w transpose x I plus b. So I'm just writing pseudocode that will look like Python, but it will not exactly work. But I'm just hoping to get the concept clear, guys. So this will be AI is equal to sigma z I. Now j is going to look like j plus equal to yi. I'm not going to write superscript, but every I am going to write that, assume that to be superscript, alright. Log of a I plus 1 minus y I log of 1 minus a I, and we are going to wrap that thing, and after that we are going to have this thing now. D of zi is going to be equal to a of I minus y of I, and d of w1 is going to be x1 of I dz of I, assuming n for this example n is true, assuming that, and g of w2 is going to be x2 of I dz of I. Now for this example I'm just going to assume uh, m is true, but it can be like a bigger number, so it can be so big as a number that you guys might have to use the for loop. So we are going to do this thing as well. So this is going to be like cause we are going to compute the averages, right? So we're going to do this, then g of wi is going to be m. We're going to divide this as well, and then g of w I2 is going to be m as well. Then g of b is going to be equal to m as well. Now with these calculated, we calculated the derivatives of the cost function j with respect to w1, w2 and b. Now having this thing, alright, I just figured out how to drag the thing. That's awesome. I have to click with the right click. Alright, so when we were going to write this equation, so g of w1 is going to be g of j1 by g of w1, and w1 is going to be w1 minus rate of learning into g of w1. Then w2 is going to be w2 minus rate of learning minus d of w2. Then b will be like b minus rate of learning into g of b, and this will be correct value for the cost function. So we are going to have to repeat these things multiple times for just in order for us to have gradient descent. So here are two weaknesses with these calculations. So you're going to implement logistic regression with this way. You need two for loops, like one for loop that is going to be this one, and other for loop that is going to be over this one. So when we are writing deep learning code, we'll have a lot of for loops in our code, so which will make our whole algorithm run less efficiently. So in deep learning era, we'll move to like bigger and bigger data sets. So being able to implement algorithms without explicit for loop is really important, because this will help you scale bigger data sets. So here comes the vectorization concept. So with the vectorization concept, we can literally get rid of the or like all of the for loops. So that is super awesome thing. So in pre-deep learning era, vectorization was nice to have, like sometimes we speed the code, sometimes we not, but now it has become really important to learn that. So we train on large dataset and code. Our code should be efficient. So we are going to talk about the vectorizations in couple of further on. So yeah, stay tuned. I hope that you guys are doing nice, and keep grading until next time.